So yeah, today's topic is functional programming. Everyone wants to look at the screen. I think there is no Q and A. Only one Q and A. I'll check that. Uh, Once you want me to once again share the link. Okay. Yep, shared it. Yep. So functional programming. Yesterday we have learned a concept called object-oriented programming. I told you object-oriented programming is a style of programming. It is a style of programming where you will be making use of more objects. You don't care about anything. You only write more and more objects inside your code. That is called object-oriented programming. By looking at this title, can you tell me where we will be focusing more? In this is also a style of programming. Functional programming is also a paradigm of programming. We can also say a style of programming. Can you, but just by looking at the screen, like the title, on which thing we will be more focusing on? Functions. In this we'll be focusing more and more and more on functions. We don't care about objects, classes in this style of programming. We consider more and more about functions. So here we have some function types like pure function, first class functions, no side effects function, lazy evaluation function. This is statelessness, and it is immutable data. We have to write immutable kind of functions. So let's go through each and everything. Bit of theory in the start. Later on, the concept actually starts. So I already told you about immutability. Immutability is nothing but we can change the entire function, but you cannot change the parts of it. You cannot change the parts of it. It cannot be altered. That is called immutable data. What is pure functions? Pure functions are functions with no side effects. For example, let me give you a good example of pure functions. Uh, Function B, C console dot log A plus B sum of 8. Okay. I'll give you a very good example of pure function. Immutable, I hope all of you understood. Immutability in the sense, once we create a state, we should not be able to modify it or edit it. That is called immutability. Just now during the Q&A, I have shown it to you. Now, pure functions. What are pure functions? If you look at this example, now 14, if I change this to 10, is the output of my previous output and this output are it same? Is it same or is it different one? Tell me in the chat. Is my output different the previous time and this time or not? It is different, right? If I change the number here, is the output is 18? No, it becomes 9. It becomes 9. It is different. So every time when I change something outside the function, remember, understand, if any time that I change outside the function, if outside the function, if I'm making any changes and it is affecting the function's output, then we call it non-pure functions. We call it non-pure functions. Then what are pure functions, sir? Pure functions are nothing but if I take the same thing and if I put it inside a function, for example, instead of a equal to 1, if I say a comma b, and if I change here like 6, this is okay. In function call, if you change anything, that is okay. But outside the function, any other variables, any other functions, you should not change. Even if you change, that should not affect your function. Now, you want me to repeat? Okay, again I'll repeat. Let me come back. Or else, if you feel this confusion, I'll remove this also. Let's make it only A. Let's make it A. Okay. Let's make it A. Hmm? What is my output? Everyone, tell me in the chat what is my output. It's an easy one only. Pure functions, it is an easy one. 6. The output is 6. Now, understand, I'm making a change outside the function. I'm making a change outside the function. I'm doing some changes outside the function. Let's say 5. Is the answer, is the output changed, or still my output is 6? It is changed, right? The output is changed. So this is called a non-pure function. This is called a non-pure function. Pure function is a function that has to not be changed by any other thing that is affecting other than the function. For example, yeah, let's take this example. You just now I showed it, right? Or else I can write a comma b. I'll remove this. 5 comma 6. So 5 comma 6 is 11. When I give 5 and 6, the output is 11. When I always give 5 and 6, the output is 11. If how many times if I run it, is the output changing? Like for the set of inputs, the output has to be same every time. It is not changing, right? So this is called a pure function now. This is called a pure function. Now let's consider another thing. Let c equal to 10 plus c. Okay. Now it is 21. I'm not changing the function. I'm not changing the function call. Remember, I'm not changing nothing related to the function. I'm not changing nothing related to the function call. I'm changing some variable. Somewhere I'm changing a variable. Let's say 16. Did my output changed? Yes, right. This is an unpure functions. This is called non-pure function or an unpure function. Now have you understood the concept of a pure function? Because in the later on classes we will be writing pure functions. Pure functions are very good functions. It's the same as non-pure, it's only you change the way of seeing. Is it Karthika? Because c, I'm not this variable c, I'm not sending it through call. I'm not sending it through the call. I'm not sending it to the function call. I'm not receiving it in the function parameters, but I'm using a variable which is somewhere in the code. The variable c is not involved in the sum initialization, the sum declaration. It was not included, but somewhere in the code the variable c is there, and I'm using it inside the function. So if anytime I change it, this also will be changed. So that is why it is a non-pure. But now if you ask me, then sir, show me a pure one. I have to not use any variable that is not included in these two things. I should not use them. I should not use this c variable. Now this is a pure function. Because here I can change. Here I can change. But anywhere other than the code, any other code, even if I change, this output should not be changed. Did you understood the Karthikeya? Or else if you want to still make it simpler, just to check if I'm using any variables other than the function declaration. Here two arguments are there, two parameters are there. In the entire function block, I'm using only those two variables. That's it. It is a pure function. It is a pure function. If I write anything other than like let's see, somewhere it is somewhere in the code. Let's see equal to 15. And if I use that 15 anywhere, not only for addition, if I write console dot log c, even if I write like this becomes an unpure functions. This becomes a non-pure function. Why? Because I used a variable which is not given in the parameters, which is not given in the arguments, and it is a variable that is somewhere in the code. That is a non-pure. But what is the purpose? We can do something with non-pure also. But pure functions are considered to be very good functions. Pure functions, I'll tell you why. Because if you write this kind of unpure functions, what happens is, somewhere when a new developer comes to your project, he may change that variable for some reason. For example, there's a new developer coming. He changed this 15 to 28 for some reason. He has changed it. Now my function's output will be changed. He changed that variable for his function, but my function's variable will be changed. So that is the reason non-pure functions, if it is possible, we have to avoid them. We have to try to write only pure functions. That is the reason I'm taking more time to explain you pure functions. In the coming classes later on, I'll be writing only pure functions code. That's why. Yeah, we depend on parameter variable, non-parameter variables. We depend on non-parameter variables. Other than the parameters, you're depending on non-parameter variable, which is a C variable here. How to value of C pass in the function? If you want to pass it in the function, you can do it like this. Sorry, not like this. Like this, you can send it. But and here also you can add it. Now, can you tell me, is it a pure function or not? Based on your knowledge, is this a pure function or not? Previously, I have not added here, so I said it is a non-pure function. But now, is it a pure function or not? Yes, it is a pure function. It is a pure function. The answer is yes. Why? Because now this is not a variable somewhere else. This is a variable that is in the argument. This is a variable that is in the parameters. It is a pure function. It takes time. Do not worry. This is a pure function now, because that C is included in the arguments, and it is included in the parameter. The same three variables, you are using it in your block a comma b comma c, a b c. You are using it in your block, so it is a pure function. Run the code by changing the C value. Okay. It is 11. Oh, sorry, I'll do plus for no confusion purposes. Okay. It is 39. 6. I'll tell you now. Okay, 21. The output is changing, but the output is changing. But now, since only the output is changing, can you now tell this is a pure function or a non-pure function? What do you think? Is this a pure function or not a pure function? If the value is changing, the output is changing. Not pure? Is it not pure? It is still pure. Why? Because what I said in the definition when I'm explaining pure function is, for a set of inputs, for the same set of inputs, the output has to be same. For example, if I'm sending 16, 5 and 6, every time I run the code without changing the values, without touching these three values, or else let 5 comma 6 comma 16. Okay, I sent it into a function. I have sent it into that function. My output that I got is 27. And every time I run the code, the output will be 27 only. The output will be 27 only for this set of inputs. For this set of inputs that I'm sending it in the sum function, the output is always 27, no matter what. No matter what. If now you can ask me, sir, if you are changing it to 10, the output is changing. No, sir. You are changing the function's input here. You are changing the function's input here. You are changing, you are creating a new set of input, 5 comma 6 comma 10 now. It is not 16 now. You have created a new input set. Now, if for the function, it has to return 21. If I run the code how many times, it has to give me 21. It has to give me 21. But in the previous case, let's show you why it is non-pure. When it is non-pure, what happens? Okay. Now, my inputs are what? You tell me in the chat, what are my inputs? What are the function inputs? 5 comma 6. Function. Okay. What I have not run the code. Okay, it is 21. So for 5 comma 6, my function is giving me 21. Okay, it is wrong, but it is still, it is giving me some output. Okay, now let's keep on check it. Now somewhere a developer came, he has changed this 10 to 8. He has changed this 10 to 8. But still, what are my inputs, sir? What are my inputs now? When I'm running the code, what are my inputs of the function? 5 comma 6 only. 5 comma 6 only. My input is 5 comma 6 only. I am sending it to function, sir. Then what is my output now? I have not run the code. What is my output now? 19. My output is 19. Is it changed or not? For the same set of input, the output has changed. The same set of input, the output has changed. This is called a impure function, non-pure function. You can call it anything, but it's not a pure function. Did you all get the point now? I tried my level best actually. Sir, but if we take input from user, we can't know what the user input at that. How do you know pure? If the user gives some input and for that there is an output, it is okay, fine. User input or normal input can affect the function, that is exactly okay. Other than the input, if anything else is manipulating the function, then it is called a non-pure function. Inputs should manipulate function. That is why we build function. When we give a different input, we have to get different output. But other than the input, if any external factors are affecting the function, we call it non-pure function. Yeah, ABC is there, but the C is a variable which I'm using, which is somewhere else where it's not there in the parameter, it's not there in the argument. It's a non-pure one. What is the value of C pass in the function without C parameter? The value will be this only. Automatic, it's a global scope, Ravindra. This is a global variable. So automatically this function will take the value of C here. The value of C here. If I don't give any C, then see what happens. I'll get an error. C is not defined. If there is a global scope, so automatically the C value will be coming here. So that is your pure functions. Now, first class objects. Sir, what is this first class objects? First class objects are nothing but, how to put it in words? Wait, I'll check for a good example. This one you will not understand because it looks like a normal function. This one can be done. These are, you'll not understand this. I'll try to get a good example. First class objects are also your normal functions only, but there is a small difference. I'll try to find a good example in internet. This one you'll not understand because it's returning a small a comma a plus b sum. You'll not get this. I'll search for a good example. This goes into a loop. Perfect. I found something. Yeah. I'll explain you now what are first class functions. This is a very good example that I found in internet. I could have taught you this also. But the thing is, in first class objects, when we are talking about first class object, there has to be a parameter. There has to be a parameter that is a function. That is a function. That we have to have a parameter that is a function. In this example, they have not given a parameter as a function. Sorry, a function in a parameter. Here they have given, but they have not said what is this operation functions. They have not given it. So that is the reason I'm not teaching you this example, because it confuses you. It confuses you. When even first time I saw it, I got confused why there is no operation function. It confuses you. So that's why I'm giving my own example. Once to look at the screen, everyone. Coming back. Now, what are these first class objects, sir? What are these first class objects, sir? First class objects are similar to functions. They're same functions, they're functions only. But the only tiny difference that you see is in this line number 494, do you see anything different? Do you see anything like any different that you see here? First, I'll run the code. Okay, it's coming hello JavaScript. Do you see any difference? Any difference like in the parameter wise anywhere? Hello message. Yeah, that's exactly right. What I'm trying to prove is, first we'll start with 498. First we'll start with 498. In 498 we are calling a greeting function which is having say hello and JavaScript. What is this first parameter? Is it a variable? Is it a variable? No, right? It's not a variable. It's not a variable. It is a function. Where it is a function. Say hello is a function. But on but if you don't see this, how it looks? Does it look like a variable? By just, if you don't know that this is a function, does it look like a casual variable, right? This is a casual variable, yes, right? That is your first class objects. If you are giving a function, if you are sending a function as a variable in an argument to another function, we call it first class objects. First class objects. First class objects are nothing but if you are sending a function as a variable in an argument to another function, we call it first class objects. That's it. That's the story. If you see here, we are calling this greeting function, but we are giving the first parameter as say hello. We are giving the first parameter say hello, but we are sending it as a variable. That is very important. We are sending it as a variable. We are not sending it as a function. We are sending say hello and JavaScript is a string. Now come here. This now, what is hello message? What is hello message? Can anyone tell me? Once again, I'll repeat this. But yeah, what is this hello message? What is this hello message equal to? Look at the code properly, you will understand it. What it is equal to? It is equal to say hello. It is equal to say hello function, because say hello function is coming to hello message. And where we are running it? We are running it in line number 495. We are running it in line number 495. So that is your first class objects. First class objects are nothing but if you are sending a function as a per argument to another function, we call it first class objects. That's it. If you want one more example, I can give it to you. Let's say function hi return hi function greet. It takes hi message and just it takes hi message. Let's say it takes only hi message, and it says sorry, console.log hi message plus how are you. Greet hi. That's it. I hope you are getting this. This is a very easy example. I still can't bring it down. If you see this, you will understand. This hi, I can actually send it directly here, but I should not do like that. That is the concept of what do you call it? First class objects. First class objects, you have to send it as a variable. So this hi, I'm sending it as a variable in this greet function. Now if I run this code, hi, how are you? Now did you get first class objects? Why greet hi? This one. Oh, I'm sending this. I'm sending this. No, I'm sending this function here. I'm calling this function with this argument. I'm sending this function as an argument, and I'm calling this greet function. We usually call now some 5 comma 4. That, like the same way I'm calling greet hi. Hi is nothing but this function name. This also work greet. I didn't get it. This also work greet. What is this also work greet? Oh, you're saying just greet. If I send only just greet, it says hi message is not a function. Why? Because it is expecting a parameter. It is expecting a parameter. What if we don't use? Okay, let me show it to you. If we don't use this in 506, it returns a function. It's not returning an output. It's returning a function. Function hi, return hi. It is returning a function. It's not returning an output. Function hi, call in greet hi. Yeah, that's exactly right, Aman. That's exactly right. So this is what are called first class objects. If we use debugger, it will be more clear. If you want, I can show you. Where is run? Start debugging. Node.js. So now we are here. Now we are here in line number 509. Don't think what is this, suddenly what is this and all. This I'll teach you later. This is called debugging. I'll teach you later. But just see the flow. Just see the flow. Sir, it will show as applying plus. No, plus is for just concatenation. Concatenation I'm using it. So yeah, hello plus world. Yeah, concatenation. I didn't get it, Shivkumar. So I'm running it again. This comes here. Running it again. That return statement will be coming here. No, it's not there yet. So yeah, run it again. Your output is hi, how are you? First it comes here. This is getting called this. It returns that hi here, and it will be printing here. Next is your higher order functions. There are only 4 higher order functions in your entire JavaScript, and there are like for each map. Oh no, wait. There are not only 4, because with newer versions of JavaScript, there are more higher order functions added. So, but famous, there are only 4. Famous one are only 4, but still they got added because recently I read an article wherein coming in later JavaScript versions, there are more higher order functions getting added. So I should not say there are only 4. So, but the famous 4 are your for each map, reduce and filter. So what is this higher order functions? What does they look like? For example, if you try to what is this dot map? What is this dot map? I have already told you. What is this dot map? What is this dot map, dot filter, dot sort? What we say? Usually, what we call them? For each map, dot reduce, dot filter. What do we call them? What do we call them? I told you many times actually. Yeah, inbuilt functions or inbuilt methods. You can call them inbuilt functions or inbuilt methods. It is fine. Now, specifically, and also I told you, map always takes a function. Map requires a function. Map always takes a function. And if you see here, your reduce takes a function, filter takes a function, for each takes a function. So when any these kind of methods or any these kind of inbuilt functions take another function, they take another function to work on, we call them higher order functions. We call them higher order function. A higher order function that accepts a function as an argument. You can see a good. I don't remember definitions usually, but here is a exact definition of an higher order function. It is ability to take one or more functions as arguments and then return another function as its output. That is your higher order function. It is a function and it takes another function as its input. So function, this is a function returning and another function. Calling function as an argument. Yeah, you can say that. Calling function as an argument. You can say that. So if you see here, if you see in this example closely, this is a function. The function is not taking parameter here. If it is taking a parameter function here, what do we call it? Can anyone say? Here the parameter is not function. Here the parameter is array. If it takes a parameter as a function, then what do we call it? Just now I've explained you before the break. If a function takes another function as its parameter, what do we call it? First class objects. That's exactly right. We call it first class objects. But here it is not taking it as parameter. You have to look closely. It is not taking it as parameter. It is returning. It is returning a function. What it is returning? Numbers.map that takes a function and it executes something and it returns something. That is why we call it higher order function. So now you can ask me, sir, only map, reduce, filter only a inbuilt higher order functions, or we can write any other higher order function. If you take this example, here I am not using any map, reduce, or filter, nothing. What this function is doing? Can anyone tell me in one sentence what this function is doing? This and this are same actually. This function what it is doing and this function what it is doing means that here it is doing multiplication, here it is sum, but there is some similarity in between them. Concatenation, anything else that you are able to see? One important aspect is there. I want someone to find out. Summation. Okay, you're thinking about the logic. Don't think about the logic. It is returning a function. The similarity between this function and this function is, this function is taking a normal parameter, this function is also taking a normal parameter. This function is returning a function, this function is also returning a function. Function returning a function, that's exactly right. Function returning a function. This is nothing but your higher order functions. This is nothing but higher order functions. And usually higher order function, the function that is getting returned will not have a name. If you see here it does not have a name. Here also it does not have a name. Just function. No names. We don't give a name to them. Just we are returning a function. That is your higher order function. Anyone having any doubt in higher order functions, you can ask me in Q&A. I'll help you out. Next is function composition. This is an interesting one. Function composition just looks like, give an example, sir. Okay, you want an example. Wait 1 second. Let us say, okay, add 2. Okay. Add 2, 3. If I run this code, oh wait, add is not defined. Why add is not defined? It is just written here. Again, let's run the code. Oh, okay, there's no console.log, so I shall have to do console.log. Console.log, because in VS Code I told you we have to show output in console.log. Fine, that's it. Object-oriented programming. What is the purpose of it to use? This is the purpose. If there is an array, let's say that I'll give you a live example. This is an array I gave you, 1, 5, 9, 8, 6. Now my question is convert every element in this number multiplied by its double. Like 1 has to become 2, 5 has to become 10, 9 has to become 18, 8 has to become 16, 6 has to become 12. This is my question. To solve this question, this is the best solution. This is the best solution to using map. Now it takes the array for every element, it does into 2. So 1 into 2 is 2, 2 into 5 is 10, 9 into 2 is 18, 2 into 8 is 16, 16 into 2 is 12. This is a higher order function. And that is its purpose. and that is its purpose. So did you got now what is a higher order function? A function returning another function is nothing but higher order function, and this is how we call it. Add 2 will be going here. This 3 will be going to the inner function. This 3 will be going to the returned function. So add 2 plus 3 becomes 5. This is your output. Sorry, your output. I'll be moving forward. Next is function composition. What is this function composition? Till now we have seen that one function returning another function. One function returning another function. Now you tell me what is the thing that you see different here. It is very easy to find out. Just give a look at it. You will easily find out what I'm talking about. In this example, you'll find something. Here in this example, it is function returning a function. Function returning a function. What is happening in this code? Can anyone tell me? Use of multiple functions. Yeah, there are multiple functions, but how do we use them? How are we using them? How are we using them? Can anyone guess? It's simple actually. You can even, as a hint, I can show you this picture also. What is happening? What is this? What do you say? Function composition. What do you think? What is happening? Nested function? No, it's not nested function. Output 4 and 16. What is 4 and 16 to for which output? This one. Yeah, it is. It is. I think it is 4 and 16. Calling constants in another function. Once output, another input. That's exactly right. What is happening is one function's output is another function's input. If any time have you seen industrial supply chain? I'm studying business now, so I usually see that in day-to-day life. In a industrial supply chain, one, like here the food will be processed. In the next machine, it will be cutted into pieces. In the next machine, it will be put in our packets. Let's take Lay's chips. Lay's will be first, the potatoes will be cut. First it will be boiled, then it will be cut, then it will be fried, then it will be put, like they'll be putting it in packets. The same way, there is an input. If you see here closely, in line number 532, double 2 is there. Double 2. This function is getting executed. What is double 2? What it will be getting? The double 2 is nothing but 4. You will be getting 4. That 4, that first function's output is second function's input. First function's output is second function's input. Second function's output is third function input. Third function's output is fourth function's input, and goes on until and unless we get the final output. Until and unless as a coder we of it, one function's output is another function's input. One function's output is another function's input. That is nothing but function composition. That is nothing but function composition. Did you all understood now what is function composition? One function's output will be taking, and that function's output will be sending it to another function. That is nothing but function composition. If I run the code, it is 16 and 16 because I have done console.log here and here. So this is equal to this one. You can also think like this. This is exactly equal to this one. Putting a square double of 2. This is exactly equal to this one. Yes, right. Now let's move to the next one. Okay. This one you will not be using it, but you have to just know what it is. If you think that, let me tell you something. If you think that this is our traditional approach, usually even I code it in this way. 99.9% of coders will code it in this way. But if you think that, sir, this is very hard for me, sir, I have to take this output into a variable, and I have to send that output variable into another way functions here, parameter. Sir, I cannot do it, sir. Then there is an alternate approach. That alternate approach is using two function inbuilt functions called compose and pipe. They're compose and pipe, two inbuilt functions they are. What is this function and pipe? The same code that I have written here, I'll be writing it in a different way. See now, the same code. This is the same code. We use something called compose. This is a what do we say? This is actually a method. So even if you write it as Monish, it doesn't matter. But we usually call it compose, and you write it as compose only. Even if you write it as Monish, it will still work. But you write it as compose. It is a very good practice to write it as compose when we are using compose. So what these compose are? It's nothing but we use this something called someone asked me spread operator, right? So we use this three dots like dot 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 fns. We fns also you can write any name. It doesn't matter, but it is a syntax, but it is the best way to use fns. Instead of fns, you can also use any variable name. Now the first variable you will be always giving here, the second variable you will be giving it here. You'll be giving it here and here. I know it feels confusing, but trust me, this is a formula. Fns dot reduce, right? Y of f, arrow function f of y comma x. This is a function. This is a formula you need to remember when you are using compose. So when you use this formula and if you run the code, you will be getting 16. What is the use of dot dot dot? Like how many functions you give, you can give it here. If you want to give like 10 functions, you can give 10 functions. If you want to give 20 functions, it can take 20 function. Dot 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 means spread operator. How many functions you give, it can take it. So if you can remember this, because I could not change this, that is a formula given for reduce, right? And in this it works. And I'll ask you something. We can code without this. Yeah, I'm telling you, right? I have never used this compose in my life because I feel confused. My other developers feel confused. I always go with the traditional approach. This is the approach I always take. And I used composition. I used what we say. I used this function composition in my project. Trust me, I have used it, and I used a traditional approach. Don't forget this. Just remember there is something called compose, and if possible, no, understand this formula and read the syntax. Just practice 2 to 3 times. You'll get it. And there is something called pipe. Pipe is also the same thing, but instead of there will be a small formula changed. Formula change is nothing but where is that? Okay. Instead of reduce, right, it changes reduce. So let me show you something. Let me change this to, oh no, 2. Let me change this to 4. Oh, yo, why I'm getting an error and where I'm getting an error? Yep, I got 64. Ah, okay. Mm, console.log. I want to show you something. Actually, compose goes from left to right, and the pipe goes from right to left. I'll show you. Console.log. The order will be reversed. That is the difference between reduce right and reduce. The order will be reversed. Mm, But final output also I didn't get. Oh, I'm not returning. Uh, It is left to right only, right? It is left to right. Just for confirmation, I'm just checking. Mm, Here the square function is called before. Okay, okay, clear. I'm clear now. I'm just confirming few things. So yeah. Once to look at the screen, I'll tell you the difference between compose and pipe. Compose function, first double will be executed and then a square will be executed. First double will be executed, then the square will be executed. It comes in this order, like right to left. Double will be executed first. The double's output will be going to square. So square will be executed at the last. But here in pipe function, the order will be reversed. First a square will be executed and then a double will be executed. So pipe is from left to right, compose is from right to left. Now did you all got it? Pipe is from left to right, your compose is from right to left. Your compose will first execute double and then it will execute square. Your pipe will execute first square and then double. Did you get it? Did you get compose and pipe? And you need to remember this. I can't do anything for this. Fns dot reduce right y comma f gives to f of y comma x. So this is the thing. I know this one will be a bit confusing to you, but anyways, do not use this while coding. Remember this for your what we say. Remember this for your exams, MCQs, and all. But for coding, try to use traditional approach. I use traditional approach. My senior developers use traditional approach. Traditional approach is very simpler, not to make it more complex. This makes things a bit complex. Even if you're this one, have you all understood traditional approach, right? Did you all understood traditional approach at least? Once to confirm me if you are able, if have you understood traditional approach? Yeah, traditional approach, if you understood, I'm happy. Compose and pipe, just remember this, that will be enough for you for your MCQ purposes. Just remember two things: compose goes from right to left, your pipe goes from left to right, the order. Immutability in JavaScript I have already explained. Today's starting, this is the part I have explained it to you. Next is declarative and imperative. Okay. Which one, Hari? This one, immutability in string. Again, compose. You want compose. Compose is nothing but the same, like one function's output will be given to another function's input. For compose, we use this fns, which is used to take many number of functions, and the first parameter will be always given here. The first parameter, like 4 will be there, right? 4 is nothing but your x. This is your first parameter. Now fns dot reduce right y comma f gives to f of y comma x. F of y comma x is first it will execute double, then it is double of 4. What is double of 4? It is 8. It is 8. Then that 8 will be given to square. 8 square is 64. Your answer is 64. That is how it is done. In this case, in pipe, the order is reversed. The order is reversed. Order is reversed in the sense, sorry. The order is reversed in the sense, first double is executed, that is 2 square 4. Sorry, 2 into 2 is, or else I'll make 4. 4 into 2 is 8. 8 squares is 64. No, sorry. 4 square is 16. 16 into 2 is 32. So your output will be 32. Yep. First square will be executed, then the double will be executed. Did you understood, Hari? The order? Yeah. First square will be executed. 4 square is 16. 16 into 2 is 32. Here also we are giving 4 only, but first double is executed. Double is 4 into 2 is 8. 8 squares is 64. So that's why here the output is 64. Here the output is 32. Yeah, this is left to right. Here it is right to left. Pipe is always from left to right. Your compose is always from right to left. Okay, next is your declarative and imperative. Declarative and imperative are like, theoretical concepts, declarative programming and imperative programming. What is this declarative programming and what is this imperative programming? Let's take two things here. I'll show you the two things. Tell me what do you think are different. These two does the same thing. Okay. Look at the screen. Let's say I have a numbers equal to 1 comma 6 comma 8 comma 9 comma 2. Okay, I'll first comment this out. Double numbers. Everyone, once pay attention, it will be over. Oh, number. Okay. Console.log. Okay. Now, did it work? Did the first one work? Look at the screen and tell me, did the first function worked or not? Is the output correct? Yes. You're agreeing with it. Okay. Console.log double. Ah. Now, did this work? Did this down function work? Is the output correct? Is it the same output as previous? You can check it here. Is it the same output and everything same? Output same. Out function is working. All good. Yeah. The output is double of array in both the cases. Now, this function is giving you the same output. This function is giving you the same output. Then what is the difference? Then what is the difference between these three lines and these 4, 5, 6, 7, 8 lines, 7 lines? Or what is the difference? This function takes numbers as an array, gives you the same output. This function takes numbers as an input array and gives you the same output. What is the difference? Code readability. That is right actually. Number of lines. That is also right. Still any more? Written code, memory consumption, logic, memory. Okay. Actually, in a sense, what all you said, everything is correct. All your answers is correct. Now I'll explain you the concept of imperative and declarative. Declarative programming is only focusing on your outcome. It only focuses on your outcome. It doesn't care how you do it. It doesn't care how you do it. It doesn't care in the middle what you keep. It doesn't care what logic you're writing and all. It just gets there as fast as possible. Think that you're going to a destination. You're going to a destination. Declarative programming will take a flight because it doesn't care about the money, it doesn't care about the time, it has to go there, it has to go there, that's it. But let's say it cares about time, it doesn't care about money. But here imperative programming is a style where you will be writing logic in a very readable manner. You will be writing it very like basic manner, like you will be using loops, for loop, while loop. It's very like starting in the starting days how you will be writing code. That is how imperative programming looks like. Imperative programming doesn't use this fancy dot map, arrow functions. It doesn't use all those kind of things. Imperative programming, it just looks very plain, very neat, to the point, logic like that. Declarative programming is just like on the spot, numbers dot map and into two. That's it. That is called declarative programming, and this is called imperative programming. Imperative programming, like it uses code pieces like for loop, while loop, and you know what do we say? And talking about readability, right? In some cases, this is more readable than this. Can you tell me why? This is sometimes this is more readable than this. Can you tell me why? Because even once when I looked at the code, I understood this code faster than this one. Can anyone tell me why? You may think that this is more readable, but in fact, this is readable. Can anyone tell me why? Why? Like why this and less code, less number of line? Yeah, that's exactly right. Why? Because if I know what is a map, usually we only talk if we already know programming. If you already know programming, when I see numbers dot map ending to two, right, and then I can say that it's doubling, it's just doubling. But here I have to think. Result is an array. I'm starting from zero. Numbers dot length I plus plus. Okay, array from starting to numbers dot length, that is there. Okay, I'm pushing into array I into 2. Okay, then I have to think, I have to process in my mind. But here, right and there, n into 2. Okay, it is just doubling. So it becomes much more easier to understand the code. And your declarative programming uses more of higher order functions like reduce, filter, what we have, map. Those kind of higher order functions are used in your declarative code. Imperative code doesn't use it. Imperative code uses more for loop, while loop. uh, yeah, it uses something like that. Which one is good in terms of notation? Declarative. When you get into a company, if you write code like this, the manager won't get impressed. Trust me, the code works fine. Even the time complexity and for this and this is also nearly same. It's just like millisecond difference, but nearly same. But the manager won't be happy to see you this kind of code. He will be happy to see this kind of code. Do they don't follow syntax in writing code? We have to follow syntax. But you no need to stick with company standards. If the company says you to follow this kind of coding, you no need to follow it. If it works, it works. Always try to write better code. If you write better code, the manager will understand, and you may get even promotions too. Yeah, if you know .map, then only you can use this. Yeah, optimized code will be always considered for appreciation. That's right. So that is your declarative way of coding, and this is your imperative way of coding. What benefits of this functional programming? It is having less side effects because it has pure functions. It has less side effects because we are making use of pure functions. Modularity. Each task will be dividing into simpler small topics, subtopics. Expressiveness. We use something called declarative programming, which expresses more. Testing. One more thing. Functional programming is best for testing because we have something called pure functions. I have not taught you about testing, but there is something called testing in the later. While testing the code, it becomes very simpler. It's just like playing. When we are writing the code with pure functions, testing becomes very easy. Trust me, testing always becomes easy if there are pure functions. Even when taking the work, like when you get into a company, you have to pick what work you will be doing in that particular project. If I'll first see the code. If the code is having pure functions, I'll right away pick up testing. Why? Because testing becomes very easy if there are pure functions in the code. So testing becomes easy here. And next is scalability. If there is more error, you can still scale your functions. You can add more logic and you can scale them. So these are the advantages of using a functional programming.